Hey class, welcome back to the unit on area of polygons, and today we're going to start talking about the area of regular polygons. This is going to get interesting, so I'm going to make probably 3 videos for this one lesson, and we'll start with the first video to get used to some vocabulary, because we're going to learn some pretty awesome vocabulary words, so hopefully you're ready. So let's dive into some notes, okay? We're going to talk about notes. And remember, we're talking about regular polygons. And we need to remember what regular means. Okay, so it's a key word, what regular means. What regular means is that we have all sides of the polygon are congruent and all interior angles are congruent. Okay, so we got to remember what regular means. So we have a regular triangle, all 3 sides are the same, a regular pentagon, all 5 sides are congruent, and then a regular hexagon, all 6 sides are congruent. So you got to remember what regular means. And I know you're thinking right now, cats, what's with the circles? I'll get to that in a second. The reason why I'm showing circles is that we have to remember that from the center of each of these regular polygons, there's a center, and from that center, we can circumscribe a circle around that center, and it'll touch all the vertices of a regular polygon. So that's an interesting thing. Remember, a circle has 360 degrees around the center. So for each of these regular polygons, there's a center of a circle that can circumscribe, right, all of these vertices of the regular polygon. And that's what's kind of cool about regular polygons. The center of the polygon is the center of the circle, and a circle has 360 degrees. So that is a huge vocabulary concept when it comes to the word regular. Now, I have a new vocab term that you need to know. It's an awesome word, and it's called an apothem. Okay, so this word is pronounced apothem. And so to help you remember how it's pronounced, I have a picture of an opossum. Apothem, opossum. So this is our opossum, the apothem opossum. Anyhow, we have a new thing called the apothem. It's a thing. Now the thing about an apothem, it exists in a regular polygon, and it does 2 things. It bisects a vertex angle, and you're thinking, what the heck is a vertex angle? I'll show you in a second. And it bisects the side of the regular polygon. So, cats, what are you talking about? Let's take a look. Okay, so we're going to take a look at this little diagram here. So here we have a regular hexagon, and we have the center of the circle that circumscribes the regular hexagon. We have a radius from the center of the circle to one of the vertices of the regular polygon. We have a vertex angle. That is the angle in between 2 consecutive radii. That's a vertex angle. So the vertex angle is the angle in between 2 consecutive radii. Okay, so yay vocabulary. And now we have this new thing called an apothem. The apothem goes from the center to the midpoint of one of the sides of the regular polygon. So it's the distance from the center to the side of the regular polygon. That's the apothem. So the radius is the distance from the center to the vertex. The apothem is the distance from the center to the side of the polygon. Okay, so we have to see what the vocabulary term is. Remember, vocabulary is where your eyes look. Now, the cool thing about the vertex angle is how simple it is to find. The vertex angle is basically 360 degrees divided by the number of sides of the polygon. Okay, so in this case, we have a vertex angle here. It's 360 degrees divided by the number of sides, in this case 6, because there's going to be 6 triangles that are very congruent in this circle. So all of this is vocab. You must all know these notes, or else it's completely useless for us to go any further. And that's the key. So let's get to work, and hopefully we'll be able to understand these notes a little better. And we'll start with a question. Okay, so we're going to talk about angle measures first. So we're going to start with a question. We have a figure drawn here. It's a regular pentagon. So it gives us the fact that this is a regular pentagon. It has radii and an apothem drawn. We have to know the difference. The radius, remember, goes from the center to the vertex. That's the radius. The apothem, I'll put in blue, the apothem goes from the center to the side. So we must see the difference between the radius and the apothem. Okay, so remember this from our notes. That's going to be important. The question then is, what is the measure of each numbered angle? Well, we have, in this case, a regular pentagon. The first numbered angle we deal with is angle 1. Right, so hopefully you see here angle 1. Now, angle 1 is one of 5 interior angles that make up the regular pentagon. Now, if you remember from the notes again, angle 1 is a vertex angle. Angle 1 is a vertex angle, and the vertex angle is a circle, 360 degrees, divided by the number of sides. So in this case, the vertex angle is going to be 360 degrees divided by pentagon. Right? So angle 1 is going to be 360 degrees divided by the number of sides. In this case, it's going to be 5. All right? So we use our calculator, and we find out that angle 1 is going to be a measure of 72 degrees. So angle 1 is a measure of 72 degrees. So this is angle 1. Now, what about angle 2? So if you can see right in here is angle 2. Well, that's interesting because angle 2 goes from a radius to the apothem. What we have to remember about vocab is that the apothem bisects the vertex angle. So if angle 1 is 72, then angle 2 is with the apothem, it bisects 72. So angle 2 then, angle 2 is going to end up being 72, but cut in half. So our measure of angle 2 is going to be 36 degrees. So we have now found the measure of angle 2. Now, what are we going to do to find angle 3? So hopefully you've thought about this by now. Angle 3 is what rounds out a triangle. A triangle formed from the angle 2 that we have just found and a 90-degree angle that is here. So if all 3 of these angles add up to 180 degrees, we can do some work. So we know that angle 3 plus angle 2 plus 90 degrees gives us all 3 interior angles of a triangle. Okay, so angle 3 and angle 2 and 90. Angle 3, angle 2 tucked in there, and 90. That gives us all 3 things. So we can do some work. We know that angle 2 is 36. So if we have angle 3 plus 36 plus 90, and that equals 180, we can add 36 and 90. And so we have angle 3 plus 126 equaling 180. And then we just subtract 126 from both sides. Okay? And then we can easily find, well, hopefully easily anyway. So we found out that angle 3 is going to be 54. So we know that the measure of angle 3 now is 54 degrees. So we have now worked our way around angle measures. Okay, so that's how the apothem works, that's how the radius works. And just to make sure that we're good with vocab, let's do one more question, and then we'll call it a day for the video, okay? All right. So we're still doing angle measures. We've got to get our vocab right. Here we have a portion of a regular octagon. Remember what octagon means? 8 sides. And it has radii and an apothem drawn. So we've got to remember the difference between a radius in red goes down to the vertex, and the apothem in blue goes from the center to the side. We have to know the difference. That's vocab. Okay, so now we're going to find out the measure of each numbered angle. So once again, we have angle 1, which is a vertex angle. All right, and then we have angle 2, which is half of the vertex angle, and then angle 3, which we can use from the triangle interior angle sum theorem. So we have different ways that we can maneuver this. It's going to be done in the same way. So remember, angle 1 is our vertex angle. Okay, vertex angle is 360 divided by the total number of things there. So in this case, angle 1 is going to be 360, but divided by 8. So our measure of angle 1 is going to be 45 degrees, is what we get when we use our calculator for that. If we have 45 degrees, we now know the measure of angle 2. Okay, so angle 2 then would be 45 degrees, but cut in half, because what do we know about the apothem? The apothem bisects the vertex angle. So angle 2 then, the measure will be 22.5 degrees. And then angle 3 we can find by working our way around a triangle. So angle 3 can be found this way. We add our 90 degrees plus the 22.5 we had just found. Okay, so that gives us 112.5. And we subtract that from 180. So we have 180 minus 112.5. And then we get our angle 3. Turns out to be 67.5 degrees. So angle 3, 67.5 degrees. And we have now worked our way, again, around angle measures with regular polygons. And that's going to be important as we move into area. But I'm going to stop the video here. The angle measures are extremely important. We got to know our vocabulary, and we remember the notes with the apothem and the difference between that and a radius and what all this stuff means. So we'll come back for another video and learn even more. Take care.